Okay. So, our topic for today will be the review. Review lang to review summary of ref and HVAC. So, refrigeration and heating, ventilating, air conditioning. So, when we are talking about air conditioning, kailangan natin yung different properties of air. Ano ba yun? Yung temperature. Diba? Meron ka ring volume ng air. The pressure of air. Pag air conditioning. Because, kailangan mo i-consider yung mga parameters na yan when you are talking about psychrometry. Doon mo mame-measure kung ano nangyayari sa hangin. If they will be dehumidified, humidified, they will be cooled, they will be subcooled, di ba? They will be heated. Pero hindi na tayo pupunta doon. There are separate discussions about that. Nandyan na rin yan, naka-record na rin sa YouTube. Okay? Pag-uusapan na lang natin the key points kung saan pwede nating masolve yung mga problems that is given on our board exams pagdating ng air conditioning and refrigeration. First, we will focus with the notable subjects pagdating ng air conditioning. Number 1, the dry bulb temperature. Commonly, ang dry bulb temperature, yan ang measure dun sa ating temperatura, okay? Dun sa ating, tawag dito, yung sling psychrometer. Okay, kinukuha mo yan. Yung dry bulb and wet bulb. Sa psychrometry, just 2 points of the parameter nung air mo, mamimeasure mo na lahat from point 1 to point 2. Next one, yung dew point. Itong dry bulb and wet bulb, meron tong pwede nating gamitin yung ating steam tables. Pwede ring psychrometric chart, whichever you prefer. Pero pagdating kasi ng board exam, ang binibigay lang sa inyo, either psychrometric chart or steam table. Dapat alam mo yung processes kung paano ginagamit yung steam table when you are given a wet bulb and then dry bulb. Okay? Hindi ko na elaborate yan. Again, there is a separate discussion about that. Nasa YouTube na, itinuro ko na. Now, dew point. Okay? Paano makukuha yung dew point? That is the saturation temperature at the vapor pressure. Saan makukuha to? Saan makukuha yan? Makukuha mo po ito sa steam tables. Okay? Meron mga simple na tanong dyan sa dew point. Wet bulb depression. Ngayon, yung wet bulb depression, it is the difference between your temperature at dry bulb and then the wet bulb. Now, the specific volume of air. Diba? Air is a noble gas. Sorry. Air is an ideal gas. Diba? Kapag ideal gas, we are talking about PBMRT or the ideal gas law equation. Now, ang air mo has mass, it has volume, it has pressure, it has temperature, and definitely, it has a universal gas constant that is equal to what? 0.28708 kilojoule per kilogram degree Kelvin. Now, kapag SI unit, we are talking about SI unit when we are talking about English unit, that is equal to 53.34 pound-foot per pound degree runtime. Alam nyo dapat yan, ha? Now, if you are ought to find the specific volume of air, ibig sabihin, parata lang yan. No? Diba? Parata. Okay. Yung R ng air, temperature of air, dapat ito naka-absolute. And then, the pressure of air, dapat ito naka-absolute din. Okay? You can solve for the specific volume. Now, again, useful formula para makuha mo yung mass of air, gamitin mo ulit yung PBMRT. Now, there are notable conversions again pagdating ng inyong air conditioning. In 1 pound, you have 7,000 grains. Okay? Again, sa mass, meron kang 1 ton, 1 English ton, 1 E-ton. Equal to 2,000 pounds. Okay? And 2,000 pounds is simply equal to 907 kilogram. Ito pong mga notable conversions na ito, mas maiging gamitin mo siya pagdating ng air conditioning and refrigeration. Now, Paano naman malaman dyan yung universal gas constant? Pwede kasing vapor, pwedeng air, or any gas na bibigyan ka ng R at molecular weight. Now, paano masosolve yung R niya? O simply, yung R bar, hindi naman nagbabago yan eh. R bar is equal to 8.3143 kilojoule per kilomole degree Kelvin. Or that is equal to 1545 pound-foot per mole degree Rankine. Ito, mas madalas ginagamit to for SI and then English. Ito hindi na to ginagamit. Liter ATM per mole degree Kelvin. Now, para hindi na kayo nagkakabisado, hindi na kayo nagsosolve-solve, magkabisado na lang kayo. What is the R of air? That is given. Pag board exam, itong ginagamit ko. Pero pag solving natin ng practical applications, lalo na sa ating integration courses, we will use this one, 0.28708. Ngayon naman, kapag ang R ng vapor, that is simply equal to 0.4615 kilojoule per kilogram degree Kelvin. Hindi na babago yun. Now, binigay naman, hindi siya binigay, di ba? Hindi siya binigay yung R ng air, pero nagbigay sa'yo, what is the molecular weight of the air? I-assume mo ba? Hindi. Because you have a value. 29 ang, approximately 29 ang molecular weight ng air. And then the molecular weight ng vapor, that is 18. Now, sa air conditioner naman, when you are talking about the refrigerating capacity or the cooling capacity, kukunin mo yung mass of the air. Ito yung mass of air. Air lang naman ang pinalalamig mo dyan. I-multiply mo dun sa conditions at 0.1 and 0.2. Kukunin mo yung energy dun. Ano ba yung energy dun? Yun yung contained sa enthalpy. The enthalpy of the air. Entering yung iyong evaporator or your cooling load minus yung H2 that is leaving. Okay? Conditions yan. Now, with recirculation naman, ito yung mga considerations, hindi ko na i-elaborate to kasi may system to. Karaniwan hindi nagbibigay ng system doon. But pag tinanong yung sensible heat load and then latent heat load, dalawa lang naman yan. Kapag sensible heat load, ibig sabihin yan yung effect niya, cooling effect, with respect to the sensible heat. Okay? That is M is CP. CP ng ano? CP of air. Okay? What is the CP of air? That is 0.24 BTU per pound degree Rankine. How about CP niya kapag SI? That is 1.0062 kilojoule per kilogram degree Kelvin. Wag nyo kakalimutan yan. Now, for the latent heat load, kukunin mo yung enthalpy niya ng vapor. Ano yung enthalpy of the vapor? Hey, that is 2442 kilojoule per kilogram. Kapag latent heat load, ibig sabihin sa sensible heat, yung air mo nag-absorb lang ng heat or natanggalan ng heat. Okay? And it is related with the change of the temperature, dry bulb. Yung latent heat load mo, that is yung moisture niya affected. Okay? Yung moisture lang niya affected. Ibig sabihin, nagkaroon ka ng change in phases. Okay? Now, you will talk about SHR and then LHR. Itong SHR common, pinibigay ito sa board exam eh. Paano malalaman yung SHR? SHR, sensible heat ratio. Anong babasihan mo dyan? Yung total heat mo kasi is the total heat or the sum nung latent heat load and then the sensible heat load. Now, pag sinabing sensible heat, di ang gagamitin mo numerator will be sensible heat. Kapag latent heat, ang gagamitin mo, the latent heat. Very basic, di ba? Ito, yung air mixing. Kung meron ka ditong duct na ganyan, letter Y. Okay. Siyempre, yung mass dito, mass total will be equal to yung mass 1, mass 2. Ganyan lang yun. Okay? Kung i-consider mo naman yung energy balances nila or yung energy capacity, yung energy in will be energy out. Ito yung in mo, ito yung out. Kaya mo multiply mo sila dun sa kanilang enthalpy. Okay? O, pareho lang to nung refrigerating capacity. Commonly, binibigay naman sa inyong board exam yung mga enthalpies niya. Malabo na lang, maliban na lang kung talagang masipag kayo, hanapin niyo yung pinakasaktong enthalpy niya sa bibigay sa inyong chart or sa table. Now, humidity ratio that is equal to 0.622 PV over PA. Yung PV mo, makukuha mo saan to? Temperature dry bulb. That is the pressure at temperature dry bulb. Yung PV. Now, how about yung saan ba yung RH dito? Ay, RH o PV. Ayan, partial pressure of the vapor. Yung PSAT at DB saturation tables, makukuha mo yun. Ito palang PV, the partial pressure of the vapor. Saan makukuha? Commonly given dito sa RH. Ito kasi, masasolve mo ito. Itong PA is equal yan sa pressure nung na outside, okay? Yung pressure niya sa ambient pressure minus or the absolute pressure nung tawag dito surrounding atmospheric minus the pressure ng vapor. Yun. Now the enthalpy. Ngayon, when you are given the dry bulb, okay? Yung dry bulb niya is temperature ng dry bulb. Multiply mo ng CP plus W, ano yung W? Ayun, humidity ratio at the given temperature multiplied to Hg. Ngayon, yung Hg na yun nahanapin mo, paano mo mahanap yan? Ngayon, pag wala kang chart, ito ang estimation niya. 2501 plus 1.88 dB degree Celsius. Okay, degree Celsius yan. Kapag naman degree Fahrenheit, 1061 plus 0.45, multiply mo nung dry bulb na naka Fahrenheit. Ganun yun. Ito yung estimation niya. Ngayon, pwede naman kapag sinabing water, okay? Paano mo masasabing makuha mo yung enthalpy ng water? Ngayon, this is restricted only from 0 to close to 99 degrees Celsius, even 100 to 100, okay? Paano makukuha yan? Degrees Celsius. Now, yung H niya will be multiplied mo na lang 4.187. Tapos multiply mo nung temperature niya from 0 to 100. Temperature ng water. Yan. From 0 to 99 or 100 lang pwedeng gamitin to only for that estimation. Ngayon, paglampas na dyan, hindi mo na pwedeng estimate gamit yan. Now, you are given Abjan formula in order for you to find PV. Ito, magagamit mo ito. If meron kang steam tables, this is restricted only kung meron ka talagang steam table kasi doon mahanapin yung values niya. Yung Abjan formula naman, for English ito, and then SI, naka-state na dito, and you can have the copy. For the degree of saturation, yan, mostly gagamitin nyo talaga ng chart and then tables. Sensible heating and cooling, yung mga formula. Heating and humidifying, and then the rundown of your Lily's formula para makuha mo yung mga pressure and PSAT. Okay, ito yan. Yung PV will be found yung pressure saturated at dew point temperature, hindi dew point pressure, dew point temperature. Okay. Now, for the, ito, kahit di ko na i-discuss to. So, bypass factor. Okay, yung bypass factor, that is the mean temperature na ibibigay sa'yo minus yung temperature at the outlet of the cooling coil divided by the mean temperature minus the inlet temperature of the cooling coil. Paano makuha yung mean? Binibigay yan. Or, kung hindi talaga ibigay, ikunin mo yung average nung inlet and outlet. Yan. Then, the contact factor, that is 1 minus the bypass factor. And, dito, pupunta tayo ng cooling tower. At your cooling towers naman, yan, yung cooling towers nyo naman, i-consider nyo lang naman yung in and out dyan. On the left side, to hatiin natin. On the left side of your cooling tower, this will be water. On the right side of your, yun nandito sa right side, this will be air. Kaya lang, yung nasa baba, dito naman yung magiging makeup. Ano ibig sabihin yan? Makeup, kapag Kapag medyo pinawisan ka na, di ba? Pag nagpawis ka na, mawala ka ng tubig sa katawan, di makeup ka niya, ayos-ayos. Yun lang yun. The word for makeup, yung makeup for the losses. Ganun lang yun. Now, paano malalaman yung heat rejected on the condenser? Ito yung heat rejected on the condenser. Condenser side, to the left side, yung mass in will be the mass out. Mass in will be the mass out. M ng Cp delta T. T3, which is the hot side. And then T4, which is the cold side. On the water side. Ngayon, paano yan? Kapag English units, ito po yung kanyang shortcut. Ito yung general formula. If English units, if English units, gamitin mo ito. Yung Q, dapat makukuha mo dito is in BTU per minute. Anong formula niyan? The 8.33. B, ito naka-gallons per minute. Tapos yung delta T mo, dapat naka-degree Fahrenheit. Yan. Tapos ito naka-GPM. Convert mo lang yan. Okay? So, yung heat lost on water will be accounted for the heat gain ng air. Ito yung formula niya. This M1 is the mass of air, M3 is the mass of the water. Okay? Ito yung enthalpies at inlet and outlet. Dito, air in and air out. Saan nyo makuha yan? Steam tables. And then for the range and approach, the range is the measure of the effectivity ng inyong cooling tower. Mas malaki yung range, mas maganda yung cooling tower mo. Ibig sabihin, mas malaki yung difference. So, T3 minus T4. Now, the approach will be T4 minus T wet bulb nung inlet air. Now, for the cooling tower efficiency, that is equal to R over R plus A. Very basic lang. Or, T3 minus T4 divided by T3 minus T wet bulb. For dryers, mas maganda to paliwanag ko sa inyo kapag mayroong problems. Yan. For ducts, ito na yung mga formula niya. And then for refrigeration, basic lang naman yan. Okay? Ito sa ako na ito i-discuss. Now, for constant used in refrigeration, that is 1 TOR or tons of refrigeration, that is equal to 3.5167 kilowatts, equal to 4.716 HP, or that is equal to 12,000 BTU per hour and 200 BTU per minute. Dito hindi ka malilito. Ngayon, yung 12,000, ano mas malaki? Hour o minute? Mas malaki yung hour, di ba? So, that is 12,000. Ngayon, pag mas maliit, minute, 200 lang. Ito na yun, yung 1 ton. Gamit siya. Now, ito, madali na ito. Yan, di ko na ituturo yan. Kasi graphing lang naman yan. Okay, pag sinabi ng heat pump naman, COP equal to HP. COP, performance factor, that is QR divided by worknet. COP ng ref plus 1. Or kapag sinabi naman, the capacity in HP per ton, that will be equal to 4.71 multiplied to E, yung efficiency of cooling, divided by 1 minus E. Now, EER, ito yung tinitignan natin sa mga commonly tinatawag din to EEF. Sa mga ref mo, makikita mo yan, yung dilaw na papel, EER ang tawag doon. Mas mataas na EER, mas maganda yung inyong cooling. Now, in order for you to get yung EER, that is equal to 3.412, multiply mo lang yung COP. And what is COP? COP, work net over QA. Yun lang yun. Or QA divided by work ng compressor. Yun. So, much for that. Mas maganda i-discuss ko sa inyo ng solving of the problem. Lalong-lalo na to, yung ice refrigeration and then yung sa tawag dito, cooling load. Okay? So, let us go with the discussion ng inyong problems. Yung. So, let us start with this one. A Freon 12 wastewater system operating at 5 degrees suction temperature and 40 degrees condensing temperature. Kunwari, hindi natin alam yung mga H niya. Nahanapin mo ngayon sa graph. Ano ba yung Freon 12? That is R12. Ngayon, paano ba pinapangalanan yung R12 na yan? nandito yung pangalan niya. R12, okay? R12, R12, R12. Ayan, oh. If 0, 1, 2. Okay? Ito yung nandito, 0, number of carbon, ibig sabihin walang carbon. Number of hydrogen, 1, 1 din. Plus 1, o di dalawa. Retain the fluorine number. Ilan yung fluorine dito? Dalawa. Okay, R12 na yun. Ganun yung naming niya. Okay? R22, ganun din. Ilan ang carbon? 0. 0 carbon. Okay? Yung H niya, ilan? 2, 22, 3. Plus 1 eh. Tapos, retain mo yung fluorine number. R22, di dalawa. O, diba? Ganun lang pag naming niya. O, diba? Kuwari, nag-ano na tayo. Nagkaroon na tayo ng nahanap na natin sa graph. Nahanap natin si HG, nahanap natin si HF, and then si H. Ito yung H2. Okay? Meron tayong evaporator load or QA. QREP na yan. QREP. 5 tons. Ano bang pinagmaminus natin kapag ganito? We say that this is HF. Ngayon, pag nag-graph tayo, kopyahin ko yung nanditong graph. Okay? pH diagram. Okay? Ganyan, pH diagram yan, ha? This is the pH diagram. Yung H mo is 377. I think that is H2. Yung HG niya, nandito. HG. Dito, HF lang to. HF, andito. Mababa mo dito. Okay? Mababa mo yan. Condensing. After condensing, nandito yung HG. Saturated eh. And then, nandito siya. Ito yung condensing mo. Okay, this is H2. Ito yun, 377. Dito, HG, this is 5 degrees Celsius. Okay? That is 353.6 kilojoule per kilogram. Tapos dito, HF niya is 238. Ganun din dito, equal yan. Kasi throttling process eh. Equal lang kanyang H. Ayan. Nahanap mo na yung value. Kumari, di ba? Green up muna. Very basic na yan. What is QA? Balik natin dito. Kung di mo na alala, what is QA? Ang QA mo is mass of the refrigerant, H1 minus H4. That is a refrigerating effect. Yung work compressor mo is MR, H2 minus H1. And then the heat reject is H2 minus H3. Basic na yun. Okay? Anong hinahanap? How many GPM must be circulated through the condenser? Condenser dito. So, ito yung condenser mo, di ba? Meron kang cooling coil dito. And then, nandito yung lumabas dyan. Which is, this is 3, 1, 2, and 4. This is 3. This is 2. Pero ang binigay sa'yo is the evaporator load. Meron ka dito. Yung evaporator load mo dito. Evaporator, anong pumasok dito? Edi 4, and then 1. Dito, QR. Dito, pumasok yung cooling effect, QA. If meron kang QA, solve muna natin. QA is equal to mass of the refrigerant multiplied to H1 minus H4. And this is equal to 5 tons. Okay? 5 tor equal to MR. Yung H1 mo is given na dyan. Ayun, no? 353.6 minus H4, that is 238.5 kilojoule per kilogram. Kaya lang i-convert natin to into kilowatts para makuha natin. So, MR now will be equal to 5 tons divided by 353.6 minus 238.5 kilojoule per kilogram. Ilang kilowatts per 1 ton? So, 3.5167. Check mo dyan. Nandito yan, oh. Kung nalilimutan mo, ayan. 3.5167. Very basic. Kilowatt o di kilojoule every second divided by 1 ton. Oh. Cancel natin yung value. Ay, value tuloy. Yung same units. Ang lalabas dapat dyan is kilogram per second. Okay. What will be the mass of the refrigerant that is recirculating dun sa ating system? That is 5 times 3.5167 divide by 353.6 minus 238.5. The answer will be, MR mo. MR. Meron ka ng MR. 0.1528 kilogram in every second. That is the one recirculating on your system. Tama yan. Anong hinahanap mo dyan? Anong hinahanap mo dyan? Yung circulated in the condenser. QR, very basic. QR yan. Nasaan yung QR dyan? Diba ang formula dyan ng QR mo? Ngayon, in GPM, ayun, kailangan natin yung QR. Yung QR mo, hanapin natin. Kaya lang, ang gusto kong unit dito in BTU per minute. Bakit? Di ba meron tayong formula sa QR na 8.33 yung delta B, ito GPM to, multiply to delta F. Delta F. Okay? Kaya lang, mas gusto kong gamitin yung hindi nyo alam. Okay? Hindi na i-discuss sa inyo. Okay? Huwag natin gamitin to. Huwag natin gamitin complicated. Yung alam nyo lang. Yung alam nyo lang. Ano bang meron sa QR? Diba QR? O the MR multiplied to H2 minus H3. Ganun lang. Very basic. Tapos, yung cooling water. The condenser selected, 7 degrees temperature rise. Temperature rise is 7 degrees. Ibig sabihin, meron kang delta T. Okay? Given na delta T dito is equal to 7 degrees Celsius or Celsius degree. Change in temperature, baliktad na yan. Okay? Pag Celsius degree, yan yung delta T. That is equal to, okay? Yung sa Q ng ref, QR, nung sa refrigeration, sa condenser, tapos heat gain naman nung sa water. Yan. Yung mga nag-steam sa akin dyan, mayroong mga shortcut dito. So, mass of the refrigerant multiplied to H2 minus H3 multiplied to mass of water. Tapos, CP ng water, delta T. Kaya lang, ang hinahanap kasi dito, density, di ba? Density tuloy volume. Di ba? Relating to. Simple, di ba? Simple thermodynamics, mass. Saan ba yung density? Mass over volume. Basic yan. Di ba? Density is equal to mass over volume. Hinahanap natin volume. Volume is equal to mass over density. Ano lang? Di ba? Ito, mass. Reform natin. Mass is equal to volume times density. Ito ang gagamitin natin. So, equal to volume, density ng water, CP ng water, delta T. MR, H2, minus H3. Meron tayong problema. Naka-English units, pero lahat naka-SI. Okay, leave it be. Leave it be. Walang problema dun. Walang problema dun. Saan tayo magko-convert? Sa dulo. Ang hinahanap natin is volume flow rate. Simple lang. Volume flow rate equal to MR H2 minus H3 divide by density CP of the water multiplied to the change in temperature. Very basic yan. Yung specific volume tuloy. Volume flow rate. Yung MR mo. Ano yung MR mo? 0.1528 kilogram in every second. Ano yung H2? 377 kung di ako nagkakamali. 377 minus 238. Check nyo kung 238 nga. 0.5 kilojoule per kilogram. Meron ka na yan. Yung density ng water. Density of water. Anong natatandaan nyo sa mga turo ko? Pwede to, di ba? 1 kilogram in every liter. Or 1,000. 1,000 kilogram per meter cube. Kapag yung English units naman, 62.4. Same lang yan ang specific weight. Pound per foot cube. Yan yun. So, density, 1 kilogram in every liter. Multiply to CP of water, 4.187 or 186, pwede na yun. 187 kilojoule per kilogram, degree Kelvin. 186, pareho lang yun. 4.187, pareho lang yun. Walang pinag-iba yan. Delta T, 7 Celsius degree. And that is, change in temperature. Cancelable na yung delta T dyan. Tsaka yung Kelvin, tsaka yung C. O, cancel. Kilojoule, kilojoule, kilogram, kilogram. Kilogram, kilogram. Pinukuha natin, di ba? GPM. Ito, liter per second. O, minute, di ba? O, di multiply ko tong second. Problema ba yun? O, multiply ko yung second ng ilan? 60 seconds in every minute. O, yung liter, tataas yan, di ba? Aakyat yung liter mo dito. O, liter, gallons. Ilang liters in every gallon? Huwag mong kalimutan yung kaibigan. There are. Ilan? 1 gallon is equal to 3.785 liters. Meron na. Anong unit natin? Cancel ulit natin yung mga nandyan. Liter, second, seconds, liter. Ang natira, gallon per minute. Very basic. Diba? Kuha na natin. So, 4.1528 multiplied to 377 minus 238.5 times 60 divide by 4.187 times 7 times 3.785. The answer is 11.44 and that is very basic. Okay? Basic. 11.4 gallons per minute. 11.45 GPM. Basic yung problem natin. Another problem. Mamimili na lang ako dahil last problem na to. O, ito. Product load, di ba? Pag product load, titignan mo muna how many tons of refrigeration are required to produce 10 metric tons of ice per day at negative 10 degrees Celsius. Kung saan siya magmumula from of raw water at 22 degrees Celsius if miscellaneous losses are 1.15 tuloy. 15% of the product load. Now for the product load, yan yung magiging total na gagastusin mong energy to turn water into ice or ice into water. Okay? To produce 10 metric tons of ice per day. Ibig sabihin, ang sinasabi dito, that is not the capacity. Okay? Hindi siya yung gagugulin mong energy para gumawa ng ice per day. That is the capacity or the amount of ice na mapoproduce niya in terms of mass. Common misconception dito, 10 metric tons, sinabi lang 10 metric tons, ibig sabihin yun yung gugugulin niyang energy or that is 10 metric tons na 10 tons. Yan. Paano ko sinabing hindi metric tons? 10 tons of ice per day. Ibig sabihin, i-consider mo na siya na ba siyang tons of refrigeration? Hindi. Lagi mo i-consider na siya yung mass. Okay? Ako kasi noon, dinodrawing ko yan. Diba? Marami akong time noon pag ako nag-solve. Mabilis kasi ako mag-solve. Ngayon, ang condition dito, saan ba nagmula? From raw water. Okay? May tubig ka dito na 22 degrees Celsius. Diba? Hindi naman yung tubig mo magiging yelo kagad yan. Bago maging yelo yan, yung tubig mo at 0 degrees Celsius. Ganun pa rin yun. Ngayon, yung ice mo, magte-turn yan. Magiging ice yan at 0 degrees Celsius din. Oh, ano nang tawag doon? Nag-change ng phase without changing temperature. Ang tawag doon is latent heat of fusion. Meron kang change of phase but without a change in temperature. Okay? Ang paliwanag doon, di ba? Ganito yan. Kapag gagawa ka ng product load, yung product load mo, magsimula ka doon sa, sinabi niya kung saan siya magsimula. Kumari, tubig. Yung tubig, hindi kagad niya magiging ice. Dadaan niya sa proseso magiging 0 degrees Celsius until such time na magiging ice siya at 0 degrees Celsius. And after that, further cooling na yon ang tawag doon. After cooling na, bababa pa yung temperatura niya. Up to negative 10 degrees Celsius na ice. Mas maganda i-drawing mo yung figure. Pasensya na sa drawing ko, ang pangit. That is negative 10 degrees Celsius. Ngayon, meron ka ditong produce na heat, load, dito load, meron kang load. Okay? 3 proseso, pero pag-iisahin lang natin. Okay, the total heat load, yan, will be equal to mass total and then all the processes na meron ka dyan. Himay-himayin ko muna, ha? Yung ginamit mo dito, ano ba yan? Meron ka ba ditong change in phase? Wala kang change in phase dito, kaya ang gagamitin mo is CP ng water. Multiply to the change in temperature. From 22 to temperature 1. Ito yung process 1 mo. Yung process 2, meron kang naging change in phase. Ibig sabihin, meron kang heats of fusion. Plus, yung mass na total nun, i-multiply mo ng heat of fusion. Diba? Tama ba ako? Na yung amount ng mass nito will be equal sa amount ng mass nito and then amount ng mass nito, hindi magbabago yan. Plus, dito yung 2 mo. Nagkaroon ka ulit dito ng change in temperature na again. Di M total, CP ng ice. Ice na yan eh. Diba? Yung tubig naging ice na. Delta T at process dito sa 3. Anong CP ng ice? The CP of ice is always 50% of that ng water. Okay, tandaan niyo yan. Ngayon, isang solving to. Papakita ko sa inyo. M total, CP ng water, tapos delta T1 plus HF plus CP ng ice, tapos delta T3. Kaya lang, you will account for 15% of the losses. Hindi naman perfect yung system mo eh. 'Di ba? Yung ginugulan mo ng energy, may losses ka pang 50%. Sir, nawalan po tayo. Hindi. Yung 15% na yun, yung losses na yun, you will account for that. Anong ginagawa mo? Kunwari, ikaw meron kang 'di ba? Meron kang pera. Anong ginagawa mo kapag kinukulang yung iba mong kasama? 'Di ba nag-aabono ka? Ibig sabihin, part of that will be iaabono mo. Ibig sabihin, i-multiply mo ito. Nung one part, ibig sabihin 100% of the system calculated plus the losses. Okay? Ganun yun. So, solve natin. Yung empty is 10 metric tons. Okay? 10 metric tons. Anong conversion yan? Mamaya na po. Yung CP ng water, that is 4.187 kilojoule per kilogram degree Kelvin. Multiply to, naging change in temperature of 22 tsaka 0. Di 22 minus 0. Hindi negative yan. Unahin mo yung malaki. Saan siya nagmula? 22. Naging 0. So, Celsius degree na to or Kelvin na to. Plus, HF. Ano ba HF ng ice? Okay, nakalimutan nila kung nasaan. Anong HF ng ice dyan? Okay, nandito yan sa baba. Ayun LF, that is 335 kilojoule per kilogram. Okay? Ang CP ng water, 4.187, 1 siya kapag English. Lahat dito vaporization, that is 2257. Kapag LF naman, kapag English units, 144. 970. Madaling tandaan. Okay, nasan tayo? Ayun, nandito na tayo. So, sa HF, that is 335 kilojoule per kilogram. Walang degree Kelvin ha. Plus, yung CP ng ice, o di 1/2, 4.187 divide by 2 kilojoule per kilogram degree Kelvin. And then, multiply mo ng temperature change. Okay. Saan ka nagmula? 0. Minus ulit. Minus 10. Ano yan? Degree Kelvin na. And then yung compute, hindi pa tapos sir. Meron ka pang 1 plus 0.15. Kukonsider mo yung losses eh. Kompleto na ba sir? Metric tons. Dapat dyan. Kilograms. Yung metric ton mo, multiply mo. Ilang tons per kilogram or ilang kilograms per ton? You have 1,000 kilogram. in 1 metric ton. Now, we cancel all the same units. Okay? May hinihingi ba diyang unit sa huli? Okay. How many tons of refrigeration? So, TOR. Mamaya natin convert. Okay? Solve muna natin. So, empty. Consider natin to empty. Yan. Tanggalin natin. Ice, ayan. 10 empty. Per day pala. May nakalimutan ako. Per day. Per day. Dapat maging kilowatts to. 1 day. Ilang hours per day? You have 1 day. 1 day, isang araw. 24 hours. Ngayon, ilang seconds per hour? You have 3,600 seconds in 1 hour. Haba, no? Yeah. Cancel natin same units. Okay. Ang lalabas dapat dito, kilojoule per hour, per second. So, empty, kilogram, tanggalin natin yan. Kilogram, kilojoule, degree Kelvin, hindi pala yung kilojoule. Yung nga, Kelvin, kilogram, yung day, kilogram, Kelvin, tapos hours, day, hours. Ang natira, kilojoule in every second. That is in kilowatt. Okay? Kilowatt na yan, tandaan nyo unit niya. So now, you have kilowatt. Compute natin. Calculator, sa pindutan. Unahin nyo nasa loob, mas madali yan. Inuna kayo nasa loob, 4.187 times 22 plus 335 plus 4.187 divide by 2. Ano na lang? 4.187 divide by 2 times 10. Kasi negative yan eh. Negative, positive na. Times mo ng 1.5. Okay? Times 10. Ba't doble? Yan, times 10. May kulang pa. Kulang pa yan, ha? Times 1,000. Divided by 24 times 3,600. The answer is, ilang kilowatt? 77. Anong ano niyan? Anong kanyang conversion? 3.517, di ba? Multiply mo dito. 1 tor. 3.517. 5167 kilowatts. 77.7863. Divide ko na agad. 3.5167. 22. Very basic. 22.12 torrs. Okay? Very basic yung problem. Okay? I think that will be enough kasi sobrang dami na rin nung naibigay kong problems. Okay? How ironic, no? Dami ko ng problem na binigay. So that will be all, and then let's continue our discussion next meeting.